We're recording now, and I am trying to get my screen organized here. Apologies. Dun-dun-dun-dun. Okay, I'm back, and I'm back. So I've received some emails there, and I've taught this course there a couple times, and how do you say it there? There's this crunch at the end, and that's how this one goes. And we've lost a week because it's only a 13-week semester, right? So normally I would have 2 weeks of review, but we've only got one, and that's all right. And the I was planning on going over last week's PowerPoint again, not as in detail, but just because some people, I guess, 8 o'clock classes are tough during these times for sure. So we're going to go over week 11 PowerPoint again, just as a recap. And I'm going to, there was an issue there on the assignment 2. Totally apologies on my part. I guess I wanted to do an e-copy, an e-portal as well as a paper copy because, you know what I mean, I'm trying to, some people like paper copy, some people like e-copy, so I'm trying to do as best I can, and there was an error on it. But don't worry though, when the assignments are all uploaded there, it'll all work out in your favor, so everything's good. And I have a number of students kicking around. They're going to show up probably around 9, and we're going to go over some questions there they have. So, you know what I mean? For the next couple of hours, you guys can just please ask as many questions as you can. The assignment absolutely replicates the quiz, and the quiz is just indicative of what the test will be. So we're going to go over the week 11 PowerPoint again and ask questions. That's what we're here to do, because next week there is your test 3. Your quiz 3 will open up there. I'm thinking there lunchtime or something. I'm going to try and do the same thing, but the assignment 2, I kind of did it on a spur of the moment thing. This one here, quiz 3, I want to give you guys a paper copy, so that for those of you guys who have a printer or like doing things like that, you can just putter away on the quiz there for a week. And then when you're ready to enter your answers in, whenever you want to there, you'll have the e-portal that should replicate. And that's the plan. I'm trying to hit as many different learning styles as I can. And I want you guys to get out of here with the best mark possible. So if there's any errors, and there was one there, I sent an announcement out there last night. Don't worry, it's all good. Once all the assignments are in, then I can go and clean them all up. I can't change anything now, but it's all right. One of the answers there, there's 2 answers there I don't want you guys to, or 2 questions there I don't want you guys to worry about. There's an error. There's 2 questions. Go check the announcements there, and that's what that is. Don't worry about it. It's all good. It was on it. That's totally on me. Trying. I don't know. It is what it is. But don't worry about it. Questions there. Come with lots of them there today. I have more students that'll be coming at around 9 or so. So stick around. You've got me. We'll get it all done. And I know this stuff is new, and but don't worry. Once it clicks, it'll click. So how are you guys doing there? I see Elena and Brandon, Logan, Jesse, Jenna, Megan, and 2 Megans. Very good. So no, for those 2 questions there, just answer anything. That's all you're looking there for. For the 2 questions there that that there was an error, that there was errors, just post anything. I'm just going to delete them anyway. Okay, so or make them worth 0. So don't worry about those 2 questions there that I posted in the announcements. Yeah, so everything is going all right. There's still as I said there in the announcements, I've got assignments coming in through email, and it's mashed potatoes. So my plan is there this afternoon is to I still have some quizzes there from quiz 1 that you know what I mean, people have their issues. There is family or medical. Those are the two issues there that I can work with. Okay, and some people who've talked to me, they've get those into me. You've spoken to me, okay, and this is a message there for the people there that have spoken to me. Get those into me because we've got a week there until basically we're all done. Okay, so just to recap again, we're going to go over week 11 PowerPoint again, and this is your chance to ask questions because, as I said, the week 11 PowerPoint is right on top of the assignment 2, okay, which is right on top of the quiz 3, which is right on top of test 3. And honestly, the questions within the PowerPoint, I have an extra little PowerPoint there with some other questions there today that I didn't post, but I have and I will post. They're ready to go. I'll put those after we go over the week 11 PowerPoint again. But yeah, ask questions. This is where we're at. Okay, and but once this stuff clicks, it's not too bad. So if you guys are good, you guys have any questions for me at the moment? We'll just go over the stuff there that I have, and then probably around 9 o'clock or something, we'll have a free-for-all. And but please ask questions at any time. This is you guys got up at 8. Okay, all right. So ask your questions. If you guys got nothing, I got nothing. No, shut up, Ian. Let's get on with it. I like it. Let's go. Now, so let me get this organized here. Oh, and by the way, I've given you guys a Z table here, and I'll get all this up and running. Perfect. Okay. The Z table there that I'm showing you guys, that's the same one there. Just to let you guys know that there are different Z tables, and the only Z table you need to know for my course is this one here. And if you use a different Z table and a different methodology, you will get the same answer. Okay, it's just I've found that using this Z table here, it has a maximum of 0.5. Okay, so the whole trick of using this Z table is if you are, it only measures half of the standard normal curve. So you're only dealing in 0.5 and 0.5. Okay, and we'll go over this there today. If some people have told me there that they've taken other stats courses and all that, and they use a different Z table. Bingo. It's all good. You're going to get the same answer. You're going to use a different methodology, though, a different mathematical calculation. But I found that this method here that I've taught over the past couple weeks, this one here is, in my opinion, the best because it's the easiest. But other people know different ways. Go for it. Math is universal. There's 10 different ways to answer a question, quite literally. Okay, so a little trick here is if you have a printer or have some, you know what I mean, you don't need a printer, you know, you can just have it on your computer screen, but have a piece of paper of this like I have mine right here, and that's my copy. And I'm teaching this course, but you know what I mean, I have to go through the same procedure as you in order to answer a question. Okay, so I'm teaching you guys how I would do this. All right, so these Z numbers here, okay, just another word for standard deviation, and these are your probabilities. But we'll get into what all this means, okay? But for the assignment, for the quiz, for the test, you'll need this table for sure. Okay, well, let's go. I'm just going to go over this again. Okay, because as I said, there's no new information. We're just kind of walking over the same carpet here, which is what I wanted to do. Okay, and just there is a lot of information here. And if you look back, if you self-reflect on a whole we've done in this course, it's quite fantastic, actually. It's quite amazing the amount of information that's here for a quote-unquote rinky-dinky little math course. And it's not so rinky-dinky. And when you guys graduate from this course, which you guys all will, I'm not worried about that at all, you guys will have a pretty significant statistics outlook, okay, on where you guys are going. So, normal distribution and applications of this normal, standard normal distribution here. The whole idea of symmetry and skewness, okay, identify the properties there of a normal distribution, and then we get into the z values, okay, and finding the area under the curve, because you guys have seen this there before. I'm trying to zoom ahead here, and of course I can't find it. Okay, you guys have seen this, right? You know, where, and that's why we use that Z table that only goes up to, because this is a continuous distribution here. There's no gaps underneath the curve. And when we say it's a normal curve where the mean, median, mode is all the same, okay, and you have 50% of the data points on this side of the mean and 50% of the data points on this side. 50%, 50%. But we'll get into all these kinds of things there when we move on, okay? Many continuous variables. Continuous just means that there's no gaps, right? We count in decimals, these kinds of things. They have a bell-shaped, also called a Gaussian distribution, okay? And normally distributed, okay? Where they all have this shape here. Hey, where did that's what I'm looking for. See that one right there? You guys have seen this there before. I used that there for the test 2, okay? So, this is a useless slide. Don't even worry about it. I just wanted to show you there that it does get a little complicated. But we're not even hitting this, so don't even worry about this, okay? The only thing there I want you guys to take is that here we're going to deal with this is the mean, but a sample mean, you guys remember, will be an X with a bar over top of it. Here we've got population mean, because we're dealing with a population, okay? You know, that standard normal curve here. And here is your standard deviation. And you guys will remember your standard deviations. These are these constructs there that break up a normal distribution into specific percentages, okay? And we'll get there as well. So, here we go. Just idea here of your normal distribution. There's basically two bananas that compare, you know, one standard normal distribution against another, okay? And you'll see here we have two distributions. We have the brown or the gold one here, and we have a blue one here. And you'll see there that they both have the same mean, okay? But you'll look at them there, they look different, and you'll see there that the blue one is more spread out, okay? And we talked about that there with standard deviation, okay? And standard deviation, this is just an account of the spread of the data, all right? Okay, remember that table there, which I will ask you to do on test 3. So you want to go back and look at test 2 and be able there to calculate the variance. And then you square root the variance. That will give you your standard deviation. Go back to, I think it's week 9 or week 8, somewhere in there where we introduce variance and standard deviation. Okay, if there's any issues, but then you guys can talk to me there at 9 o'clock, okay? So the greater the standard deviation, or the greater the variance, really, the more spread out the data will be. And it's significant because these guys here are all kind of axised. There's an axis. There's yeah, I guess the spine of the whole thing is the mean. So you'll see here that, like, if you look at the gold distribution here, all of these points are centered around the mean. That's how this works, right? So the mean is important. Garbage truck. So there's your mean, and that's your axis. And all of these points here for either of these distributions is centered around that axis, right? And the more closely they're centered around the axis, the smaller the standard deviation. Okay? And the more spread out these data points are around the axis, the mean, the more spread out the standard deviation will be, the greater the standard deviation. So the greater the standard deviation, the greater the spread. The smaller the standard deviation, the smaller the spread. Okay? So there's two things there that we can talk about these distributions. Their mean and their standard deviation. But the very fact that all of these distributions have a mean and they have a standard deviation, we can utilize that for the sole purpose of comparing apples and oranges. And we'll get there. Okay? You look at these two. Oh, hello. Who's speaking, please?
Hello. Good morning. It's Megan Alvarenga.
All right. How's things going, Megan?
It's okay. How are you?
I'm all right. What do you got? What's your question?
So I'm wondering if we can go over how to find a certain percentage. I don't know if there's like a certain way that you can find a percentage, or if there's like a formula, or...
Oh, you mean like...
I'm just a little confused.
Okay, so you mean find a percentage. So you mean like converting decimal to percent, or what, fraction, or what do you mean? In what particular...
Well, when it asks you in our assignment, like, if this book was selected at random, find the probability of it in either a science, geological book or a math book. So I just don't know how to find that percentage.
Yeah, I think that might have been one of the questions there, that there was an error. So there was an announcement.
Okay, but I just...
We'll go over that
for sure. Okay.
All right, you got it. And finding percentage, you'll have to do that. And there was a slide there. Is it? I don't think it's in this one, but I'll bring it up right now. The whole ability of if I give you a fraction, you need to be able to change that fraction into a decimal, and or you may need to change that fraction into a percentage. And totally, that's an awesome question. And where would that be? That would be in my... Okay, I can do that. Let's have a look here. Hold on. No, week 10. Let's have a look here. Is week 10
It can be any one of the questions.
No, it's all good. That's an awesome question. And you see right here, this is the slide that you want. Okay? And this is what I want you guys to be masters at. Okay? And honestly, this is a great skill that you'll carry with you throughout the course of your life. Okay? Is being able... Is
there spaces there for us to fill in?
Oh, well, if you guys print this off, yeah. So, here, and you
can add the other ones. Okay.
So here, let's try a couple of these, man. It's all good, man. So the easiest is if I give you a fraction. So converting a fraction into a decimal, you just if you have your calculator, 1 divided by 2. And that's what a fraction actually means. Is dividing, right? So 1 divided by 2 gives us 0.5. And now there is a relationship between decimal and percent. And the relationship is, if I give you the decimal and I want you to convert to a percent, okay, multiply it by 100. Because percent is just another word for out of 100. So if you look at 50%, that just means 50 out of 100. And you just take that decimal and you multiply by 100, or you just move the decimal over 2 places because there's 2 zeros in 100, right? So you just go 1, okay, and that'll turn into 50. Move the decimal 1 space and then another space. And what do you put in that space? A 0, and there's your 50%. A decimal here, and here I didn't give you a fraction, or I didn't give you the percent. So what do? Well, if I give you the decimal, should be not too bad to convert that into a percent. Multiply that by 100, okay? So 0.30 times 100 is 30%, okay? Now, the fraction. How am I going to do that? Well, the fraction's it's not too bad. If you got the percent, what does percent mean? Okay, 30 divided by 100. Okay, and you always want to take your fractions down to their lowest, right? And so you look at 30 divided by 100. Where did I get that from? I just got it from this. Okay, and you see what you can do is you reduce it to its lowest terms, 3 out of 10. And the same banana follows for here. If I wanted to go, if I didn't have this, well, just go 50% is 50 out of 100, so 50 divided by 100. Okay, now we want to reduce it to its lowest terms. Well, I can cancel a 0 on the top. I can cancel a 0 on the bottom. They leaves me with 5 out of 10. Is there a number that's common between them? Sure, there's 5. So 5 divided by 5 is 1. 5 divided by 10 is 2. And that's where we're at right now. We can try another one. 3 divided by 5. Hopefully there, Megan, this is answering your question. If it's not, please yell at me and tell me what I can do better. But if you have 3 divided by 5, convert that there to a decimal, which would be 0.6. Okay, 3 divided by 5.
I get the conversion.
Yeah.
For me, it's just like, what's the probability of drawing something?
What do you mean?
So like there was one question, like what's the probability of drawing a king or an ace?
Okay, all right.
And out of the 52, so how would I divide from the 52 cards the probability of the ace? Because there's 4 kings and 4 aces, so would that be 8 divided by 52?
All right, so
and then you times it by 100.
I see where we're at. All right, hey man,
that's where I'm a little confused.
Let's go to the assignment, shall we? And where is it here? I don't think I'm sharing anymore. I think I've moved off sharing, and I'll be there in 2 shakes of a lamb's tail here. Dun-dun-dun-dun. That was the assignment 2. Okay, so here we go. Now let's do some sharing here, shall we? And sorry. Now, where is my that's what I'm looking for. Okay, so which question was that there, Megan?
That was C.
C, yeah.
1C.
There we go. So, what is the probability of drawing a king or an ace? So, talk to me here, and here answer as a percentage, right? And so, I've write this down somewhere that there are 52. You know what I mean? Some people have expressed to me that they don't know cards at all, and it's all right. It really is. It's not going to be a major focus of the test, for sure, or quiz or whatever. But there will be questions on there. And all I'm asking there is that there are 52 cards, and the 52 cards are broken up into 4 suits of 13, 13, 13, and 13, which adds up to be 52. And you have hearts, diamonds. These are red cards. And then we have spades and clubs. These are black cards. Okay, and there are just different, we use cards there as, because there's lots of things that we can pull questions from. That's all it is. Okay, so let me move this here. So, Megan, what's your question? Talk to me. We got you on the horn here.
That's okay. So I'm just wondering, because when I first did it, I thought that I would take the percentage of how many cards is as kings, so there'd be 4 kings.
Yeah.
So then I did the 4 divided by 52, and then I times it by 100, which gave me like 7 point something, and there's not that answer there. So then I
You
was just
got
like,
it. All right. So now you
how am
will.
I doing it wrong?
Yeah, it's all right. And you see, the whole idea is you remember there that there are a couple of key words that I'm looking for, or that you'll be looking for. And it's or and then. So there's two groups of words there you're going to be looking for when you're doing these. Or, and then the other one there is and then. So we've got this here. What is the probability of drawing a king or an ace?
Right.
So there's that word there. And whenever you see, when we're talking about probability and you see the word or, okay, that means there that you're going to pull one card and it could be either this one or this one. So how we do this there is we add our probabilities. That's the adding. Whenever you see the word or, you're going to add. So, Megan, you were correct in assuming. What was your probability? What was your math there behind getting a king?
So first I thought it was you do 4 because there's 4 kings, but now when you say you
Excellent.
add it, so it would be plus.
Excellent. So there's.
So when I do the 8, do I do 8 divided by 52?
That is an interesting hypothesis.
I don't know.
Hey, you know what? That's what all this is. And part of this course is deductive reasoning. And the just, you know what I mean, like you have all of your information on the table, and then you just kind of sit there and deduce and come up with the answer, right? And so you look at this one here. What is the probability of drawing a king or an ace? So right then and there,
Okay,
you
now I
know,
got it.
now you're into that should.
Thank you.
That's all good. That's what this is. You know what I mean? I'm on your guys' side. You guys gotta ask questions, and I love it. Bother me, hassle me, irritate me. I love it. I do, and it's good. All right. So we're just if you guys have any more questions, look, Megan just asked a question. She got an answer. So if you guys have any, just do the same. All right. Other than that, I'm just going to go through the PowerPoint again. And what we've done is we're comparing distributions. And these distributions there, they all have a mean and they all have a standard deviation. And in this case here, the means are the same, or sorry, the means are different, okay? But the standard deviations are the same, okay? And here we've got different means and different standard deviations. And you see the problem is that we can't compare apples and oranges here because our measurement systems are different. Let's say our mean here is 100 and we have our own scale, and this mean here is 45, and because it has a different standard deviation, it'll have a different scale. So we can't compare these two. All right, so that's where we're going to get into something called the standard normal. Okay, just more information there about these guys. They are unimodal, they are symmetrical, okay, and they are continuous. There's no gaps under these curves. There's no hole in the curve here, okay? The empirical formula there, you guys have seen this there before, that the exact same curves, it doesn't matter if it has this standard deviation or this standard deviation, it doesn't matter, okay? The area within the first, see here's your mean, whatever it is, okay? And then your first standard deviation, okay? Within this area here, and here we're talking about area under the curve, okay? And deals with probability. the chance of getting something divided by the chance of the total. Okay? And all we're going to be doing is going to give you guys one of these, some distribution. Okay? And what are the chances of pulling this person or this idea from in and around here somewhere? And like if I just asked you a question right here, what are the chances of pulling, here, well, let's say we're talking about apples eaten, whatever we're talking about, doesn't matter. And if I pull blindly, I want to know the probability of pulling somebody or an apple from here. Well, you just look here at my distribution, and all parameters there that fall within the first standard deviation, 68%. And we covered this there on the test 2. Okay, there was a second last page there. And the pulling somebody from within all the information within the second standard deviation is about 95%. And if you want to know the probability of pulling somebody from within 3 standard deviations, and remember, we kind of have a positive and a negative. All right. And you know what I mean? We're dealing with absolute value of area under the curve. So even though you see this area right here is above the mean, and this area here is below the mean. So to find where this area is, okay, it'll be a negative z-score. All right. To find where this area is, it'll be a positive z-score. But really, when we're dealing with absolute values there, we're just dealing with the positive absolute value of the percentages. So the area under the curve here is exactly the same as the area under the curve here, because we're dealing with probability percentages, right? So that's what we're talking about here. This is very important. This is paramount to what the quiz 3 and actually the assignment that's going out right now and the test 3. Okay, everything is based off of this. And I tested you guys on this there from test 2 because I wanted you guys to become familiar with the basic kind of, what's the word I'm looking for? The backbone of this idea, and this is the backbone of it. Okay, there's your mean. Okay, here's your first standard deviation and the percentages where these guys fall into. The area under the curve for the 2 standard deviations, okay, is 95. Within 3 is 99.7. And on test 2, I asked you guys for the areas under the curve for areas there that fell easy peasy. These areas were the standard deviation barriers. The first, the second, the third. 68%, 95%, 99.7%. That's all I was looking for test 2. But now, where we're headed now is if I gave you a point right here. All right? And I guess I can just use this one right here. So here's the same thing. And let's say what do I got here now? Let's use this one here. So here's your mean, whatever that is. Here's the first standard deviation. And I encourage you guys to do the same. And like what I do at the side of my margin here is I'll just draw a little bloop and then a line right through the center of it. There you go. Okay? Just draw a really bad, crappy graph like this, right? And there's your mean. There's your first standard deviation. There's your second. Okay, there's your second, and there you go. All right? And this will help you a lot in how to do this. Okay? Let's just go back here. Perfect. So, this is what we want you guys to know. But where we're going to be going is I'm going to give you a point in here that doesn't fall on one of these easy peasy standard deviations. So how do you figure out the probability of finding a point here or a point from here unto here? Well, we have to use what's called a Z formula. That's all it is. That's all we're going to be doing, an easy peasy formula. that will give you, if you're looking for this point right here, I want to know how many standard deviations it is from the mean. Okay, like look at this point right here. If I had this point right on this line, how many standard deviations is it away from the mean? 1. Okay, if I have this point, if I want to figure out how far from the mean this point is, and it falls right on this line, how many standard deviations is it away from the mean? 1. Just in a positive direction. Okay, but the area is the same as the area. And look at this one right here. How many standard deviations away from the mean is this point that falls right on this line? It's 2. And we covered that there in test 2. But for test 3, where we're going is I'm going to give you a point in here. And I want you to tell me how far away it is from the mean. Or better yet, what's my area under the curve for that point. All right, so that's where we're going there, and let's keep on rocking and rolling. With probability, okay, we generally use percentages. But for these guys here, if you check your z-table, okay, these are your z values, which we use the formula there to convert real numbers into a z, which we'll get into again. But all of these numbers here, these are your probabilities. And it goes up to 0.5. Okay? And you look at this number right here, 0.4382. It just means multiply by 100, and it just means 43%, 43.82%. That's all these are. These are just percentages, okay? Written as decimals. So that's why when we get into, you have to be able to flip in between fractions, decimals, and percentages at any given point in time, okay? All right. And that's why the area under a curve is 100% or 1. Okay, 1 is just another way of saying 100% because we'll write percentages, but 13.59% as a decimal. Okay, you just do the opposite. Divide by 100 and it 0.1359. Same banana. Okay, so 13.59% is equal to 0.1359. Okay, same thing. All right, getting into apples and oranges now. So, where we're at is you'll see here we have apples, and they have a mean of 68. These are the number of apples eaten. And you can actually, you see here's your first standard deviation, second, and third. And you'll see here that look at you can actually calculate, I'll give you your standard deviation for most questions. Okay, but you'll see here that my standard deviation is 9. So 9 apples, and then negative 9 apples, which takes us down to 59. So, and then another 9 apples will take us to our second standard deviation. So 95% of all data will fall within here. 99.7, okay, you see how this one works. Okay, number of oranges eaten. Okay, whoa, I have a different mean. And look, I have a completely different scale. Look at my standard deviation here. And these are real numbers. Okay, these are really the number of oranges eaten as opposed to the number of apples eaten. It's completely bogus, but I'm just trying to show you there that there's 2 different scales. Good. And, and you see that there's my mean, 1,010. And you can actually see your standard deviation, which is 20, 20, and 20, right? So there are similarities here, but the scales are completely off, and you'll see your standard deviation is all different. So how do we compare these apples and oranges? Well, we use our Z value, and we have the mean, we have our standard deviation, and now we can convert these guys into what's called the standard normal curve. And you see, it's the same banana, but now our mean is 0, okay? And our standard deviation is just simply 1 and negative 1. and 2 and negative 2, and 3 and negative 3, which is kind of the same thing as what we were doing here. But instead of a scale where the number of oranges are or the number of apples are, what we've done now is we've converted this scale where now we're counting in standard deviations. So yes, on test 2, we were only concerned about the first standard deviation. The second, 95%. The third standard deviation was 99.7. But now, as I alluded to there in the previous slide, I'm going to give you a point in here, which will be 0.67 standard deviations away from the mean. 0.67 standard deviation. So how do I figure out the curve? How do I figure out the area under the curve here? Your Z table, that table I was just showing you there. Okay, so you're going to convert a real number into a Z score. And these Z scores here, let's say 0.67. Didn't I just say that? 0.67. So 0.67. So 0.2486, 24.86%, right? So getting back to this one right here, if I had that 0.67, and I wanted to know how much area was under the curve here or here, okay, we just calculated there that this is 24.86%. And we'll get into the specifics on how to do that. But I'll just telling you there that everything we've learned is holding water. We're just taking it a little further. Again, on test 2, I gave you points on the easy peasy standard deviation. Okay, so you didn't need to calculate any Z scores. But if I give you a point or in something in between, in here or in here or in here, you got to use this Z formula. So let's try some. All right. There we go. This is the formula there you're going to use. Okay. To get your Z score, it's just going to be the number you're looking for minus the mean, which I give you, all divided by the standard deviation, which I also give you. Okay. And then you're going to get a Z number. And that Z number, you're going to go and look under the table. You remember I was right here. You see, I give you a point in here. You have to use a Z score. Well, that's what's going on here. And you'll see that a little bit of practice, that's all this is. So here I gave you guys 3 points here. This is the number of apples or oranges or watermelons or I don't know, whatever it is, okay? That's going on. So, and here I gave you guys 3 points. You know, there's your mean, 1,010, and there's your standard deviation. We've seen this scale there before a couple slides ago. And here I gave you guys 3 points. And this point here is 957, as best as you can see. The purple one here is 977. And the yellow one here is 1,041. Okay, so these are real points. Somebody went out and collected these data points. Now, if I want to standardize these, okay, you input these numbers into a Z formula, okay? And you'll see here that I've given you, there's the mean, and there's your standard deviation. I'll always give you that kind of stuff, all right? And you input, and I think I did this there for the yellow one. It's 1,041. And your formula here is this one. There's your Z formula. 1,041 minus your mean, which is 1010, all divided by 20 gives you a Z score of 1.55. So that's what's going on here. So for this yellow point here, we got a Z score of positive 1.55. Why is it positive? Because it's above the mean. Look at these guys here. The purple one and the red one here, there was 977 and 957. I input those into a Z score table or a Z formula, and I got negative 1.65 and negative 2.65. And why are they negative? They're just below the mean. That's it. Okay? But now, what we can do, and that's not what this question asks you to do, okay? This is just the whole point of taking a real number and converting it into a z-score. And what is a z-score? It's just a measurement how far away from the mean. So the yellow one here, the yellow dot, is 1.55 standard deviations away from the mean. So if we think about this, I'll just see if I can move this here. You guys know how much area is in here? 34%. You know how much area is in here? 34%. You know how much is in here as well. So how this Z table works is it measures the area under the curve from the mean. So you look at this now. If this yellow point is 1.55 standard deviations away from the mean, which we just calculated, and you'll see it's the same spot on both tables. Now you see, what we'll do is we can go 1.55 onto our table here. And I'll just pull this up here so we can see it better. So 1.55, 1.5, that's our Z value. And then we go to, is this one? Yep, right in here. So I have 0.4394. So basically what we're saying there is 43.94%. What does that mean? And you'll see here that the area under the curve from this point, because this table measures from the mean out. So that means that the area under the curve for here is 43%, or 43.9 something, whatever it was. Okay? 43%. That's all this means. All right? And if you look at this, let's look at the purple dot here. Purple was, I'm just going to get this all aligned again, we calculated that into the z-score, and that came out a negative 1.65. Well, negative just means it's below the mean. Other than that, forget about it. Okay? And how do we figure out the area under the mean or area under the curve for the purple value? Well, you just take 1.65, go to your table, 1.65. I'm just going to keep that over so I can see. 1.65. Is that 5 there? So you'll see there that 45%, 0.4505. So you'll see there that the 0.45 is the percentage under here. Because remember, this Z table counts the area under the curve from the mean out. So there we go. You find your Z score, which was negative 1.65. Go to your Z table, find for 1.65, you found, what was it, 0.4505. So that means that the area under the curve here is 45%. That's how this whole thing works. Okay? And we got lots of practice. I'm in no hurry to get out of here. We're going to stay until y'all get it. And this is just showing you the different possibilities of where we could be. Now, you see, here's a standard normal curve, okay? And I've got a Z value. Doesn't matter what it is, but it's positive, okay? Now, you're going to take this Z value and you're going to go to your Z table and you're going to get a probability. And just by looking at this, what do you think the area... Well, actually, before we do that, I'm looking for the area under the curve, so I'm looking for the probability for all of this. Okay, that's what the question is asking. All right? But remember, your table reads from the mean out. The mean out. So you look at this one here, this question is actually easier than you might think. What is the probability for this side? Well, this side here is completely soaked up. There is no gaps. There's no, the whole thing. So this is half of my curve. So what's my percentage here? Bang, 50%. Right then and there. And I'll just do that right now. 0.500. 0. Okay, so you'll see here that this side right here is 50%. So I can leave that now. Do I leave it forever? No, I'm going to come back to that. Now, whatever this Z value is, and I would give it to you, or you would calculate it, or whatever, you would go to your Z table and you would find it, and that would give you a probability, some number. It would probably come out to be like maybe 0.45. So let's just say this side here is 0.45. Okay? And I'm just going to just move this guy over here. And we're just dealing hypothetically here. Okay? Okay. So let's just say that we found out that this Z value here is 0.45. Because that's how our table reads. Our table reads from the mean out. So you look at this. What is your area under the curve? Well, you take this side and you add it to this side. So the area, the probability of choosing a banana from this shaded area, 95%. That's how this one works. Okay? Look at this. Okay? Here I have a Z value, a negative Z value. Who cares though? Negative just means that it's below the line. But you look at this one here, I am asking for the percentage or area under the curve for everything less than that value. How am I going to do that? Well, we all know that the... I'm looking for this one right here. Good. We know that our tables, okay, they measure from the mean out. So therefore now, I want to know everything from here. But my table only measures from here to here, to this Z value. Well, we know that this whole area is 0.5. So we will take a Z value, we'll go to our table, and we'll find that area for probability for here, and we subtract it from here. But I'll show you guys all these. I just wanted to show you there that there is a trick to these. Once it clicks, it's not too bad, and that's why we have a review week here. Okay? Because it will click. It will click. Look at this one right here. So here I've given you a Z value. In this case, it's a negative Z value. Okay? And I want to know the probability of choosing a banana from here. Well, bang, right off the start, I can just go like this. That whole side right there is 0.5. Done. That whole side is done. I'm going to add this number to this number eventually. But the trick of this question is I got to figure out this one. Okay? So you find your Z value, okay? And you'll see there that come on. There we go. You'll see there that the table measures from here to here. So you find your Z value, you look at your table, you find your probability, whatever that is. And just kind of looking at it, maybe it's 40%, maybe it's 45% again. I don't know, whatever it is. Okay? You take that probability, you find it, add it to this one, and therefore your probability of the area, okay, would be somewhere around 95%. Look at this one here. I could give you a Z value and ask you for everything above it. Okay? How do you do that? Well, now I'm not dealing with this whole side. So there is no 0.5 to add on this side. There isn't. Okay? You're looking at this one here. It's going to be a pretty small number. Should be around maybe 5%, maybe 6%, maybe 3%. Who knows? But it's going to be a smaller number. Okay, so how do I figure out this area? You calculate your Z value, and you remember there your table measures from here to here, out from the mean. Well, we don't want to measure this area. We want to measure this area. So you take 0.5 minus this one, and you'll get this one every time. So, okay, we got lots of practice. These are the most difficult. You see these two examples here. Because we have 0.5s, you can just add them, and you only have to deal with one Z value. Because the other half is 0.5. You just add it up, right? Okay. Same for this one. I give you one Z value. You find the probability. Look at these ones. Here I've given you, I want to find the probability between this Z value and this Z value. Standard deviation and this standard deviation. What's the area under the curve for here? Well, in this case here, you've got to do two little formulas. Okay? And so, and I'm just going to get my arrow back here because I find that that is immensely important. So, there we go. So, and you'll see that, how do we do this one? I want to find the area under the curve between this Z value and this Z value. No problemo. So, whatever your Z value is here, okay, this is negative, just means it's below the mean. Whoopie-doo. So you find your positive Z value on your table, you get a number. And looking at it, I don't know, what do you think that percentage is? It's okay, take a guess. Maybe 25%, 28%, maybe 30%, somewhere in there. Okay. And a huge part of this is being able to estimate your answer. Like, what do you think your percentage is in here? Maybe 25%, maybe 40%, so somewhere around maybe 65, 70%. Okay? Please try that guesstimate, because at the end of all your calculations, your calculator spits out an answer of 15%. Well, just looking at that area under the curve, the shaded area, 15% is wrong. So please have a look at your answers there before. Okay? Deductive reasoning again. Okay? Anticipate your answer. So you look at this Z value here, whatever it is, you just find, you go to your Z table and find your area under the probability for here. Okay? So you've got a number, let's say 0.24%, or sorry, 0.24, 24%, somewhere in there. And then what you do is the other Z value, you see, it's in between this one and this one. Guaranteed you'll see it for sure. And using that Z value right here, you go to your Z table and you find a probability for under here. And then you take this probability that you just found, you take that probability which you found earlier, you add them up, and you move on to the next question. So that's how these ones go. Guaranteed you'll see it. Okay? So that's what we're looking at there. Any questions on that? Talk to me. Confusing? It's okay. It'll come. It'll totally come. So once you have your Z tables... Oh, hello.
Hi, Ian. It's Lloyd. How are you?
Hey, Lloyd. How's it going?
I'm well, thank you.
Very good.
Regarding what you were just teaching us, in one of the questions, in one of the assignments, it's the question is a Z and a Pac-Man 1.13.
And a Pac-Man?
Yeah, so the Pac-Man that eats the larger number, so the 1.13 is actually the Z value.
Is it? All right. Well, let me, if that's on the assignment, let me, let's go to that. What question was that?
9D.
9D, eh? And you know what? I'm sorry again. Like even the numbering system on Blackboard is different, and I just apologize. It's there's just no easy way. Yeah, what do we got here? 9D. Where is it? Right here. Right here. So Z is great. Yeah. If you look at this one right here, we haven't gotten to that yet there for the PowerPoint, but if you read this, okay, 9D, okay, here we're looking for the probability, and you'll remember this notation there from before, okay, from, you remember when in week 10 we were red marbles, blue marbles, a probability of choosing a heart. So that's this probability that Z is less than 1.13. So how would you draw this? Okay, and you see, I see if I can dual screen here, if I can get this out of the way here. Da-da-da-da. So I just want to show you guys what we can do here. All right, so here we have our graph, and here we have the question. And I encourage you guys to do this, okay? Just for just assuredness. That's all you're looking for. So quick in the margin, you draw this guy here, and you have your mean right here, and I want to know the Z value there less than 1 point. The probability for Z is less than 1.13. So, and again, I'm just drawing these with no, there's my first standard deviation, 34%, 34%, right? Here's your second, and then there's your third, and there's your third. Okay, so we know our percentages, that's it. And this question is asking me, what's the probability of pulling an apple from the area Z is less than 1.13. So where is 1.13 on here? Well, this is 0, right? This is plus 1. This is negative 1. Negative 2. We keep going. This is positive 2. Okay. And positive 3, negative 3. Fine. So 1.13. Well, here's 1 and here's 2. So where do you think 1.13 is? Somewhere in here? 1.13. So this is the Z value. Sorry, maybe I should do that with a different color, but whatever. Okay. So this is your Z value of equals to 1.13. Okay. So what we want to do is we want to find the area under the curve for all of this. That's what that question is talking about. Okay. So this is, and we'll get into these kinds of things here, where Z is, we're looking for the whole area. Okay, and that relates to this one right here. Where was it? Do I have it? Yeah, it's exactly the same as this question right here, where we have a Z value, and I think the question was 1.13, whatever it is, you know, and you know that there's two parts to this. So one half of it is going to be 0.5, and the other half is going to be whatever it is. You got to calculate this. This is the half there. You got to go to your Z table. Hey, Lloyd, talk to me. What's going on? Hello?
Yes. So for that question, I actually got a 87%. So I added a 0.5 multiplied by the Z value, and I still got it wrong.
That's all right. Don't worry about this. This is where we're at there. I'll go back and check that. That was what, number 9?
Yeah, it was 9D.
Yeah. I'll have a look at it. I'll have a look.
I added a Z value plus the 0.5, and it gave me a number that was one of the options there, and I didn't understand why I got it wrong, because I was following the...
It's all good. I'll have a look at it right there. I can't... you're on... That's exactly it. I'll go have a look at it there right now. And but yeah. So doing that question there, you have to break these up into 2 pieces. So I'll go have a look at that right now after I'm done this. But that's how you do these, okay? What else we got here? Let's try some more here. This one here, again, this is how the Z table works. Okay, and it starts from the mean, works out. All right, so there's that one there. Let's have a look at this one right here. So basically the same kind of question that Lloyd just kind of brought up. Okay, so find the area to the left of Z is equal to plus 1.99. Well, you would just draw it. You don't have to draw it. Okay, but so 1.99, where would that be? That would be, can I do a different color? 1.99. Well, there's 2, so basically it's right here. And I'm looking for all the area under here. Okay? So Z, anything under Z is equal to 1.99. So, how do I do this here? Well, you realize that this half is all full. Okay, so 0.5. Okay, and that's all you can do. There's no other mathematical way to get this number other than realizing there that since this side is completely full and we're looking for it, that's 0.5. Leave it. And because the Z table works from the mean out, okay, we got to figure out this one. And you'll see there that what I did is 1.99, okay, and you get this number 0.4767, all right, and then now you add them all up and you get 97.67. So that's how this one works. Questions? Talk to me. Lloyd, is that all right? Is that what you did?
Yes.
All right, so we'll have a look at that, and if something needs to be changed, honestly, I'm so tired of Blackboard, and it looks like have you guys are all getting into your programs there for September. Have you guys heard anything there? Because I think we're going to be going to it's going to be a hybrid program again, at least for the I'm teaching in biotechnology there, and looks like, I don't know if you guys have heard anything, if you guys received any emails, but I guess it's going to be the kind of an online component again for the fall semester. But I'm just so sick and tired of Blackboard and the issues there that we've been having with it. So no, Elena, you haven't heard anything yet? Yeah, just giving you guys a heads up that wherever you guys are going, you know what I mean? If you're going to Mohawk or Cambrian or wherever you guys are going to stay at Georgian, it's all good. Just keep going. But it looks like we're going to be going for another hybrid online situation with quote-unquote essential labs being conducted in school. So it is what it is, and so I hope you guys are doing all right. Let's try another one. Actually, let's go through a couple of more of these. This is the same thing here, but we're just working from the other side. Okay, so here we're looking for the area under the curve for everything above that Z value. And you see here it's a negative 1.16. I don't care. I'm just looking for the positive. So it's 1.16. What does that say? 0.377. So there's your area under the curve for there. Plus this one's 0.5, so it should be 0.877. Okay. This one here, don't be afraid of this notation. You will see it. Don't make it scary. Here I'm just looking for the area under the curve from Z is equal to 0 to Z is equal to plus 2.32. Well, we don't have one there for Z is equal to 0, so we just go 2.32 and we get this number 48.98. There we go. There's your probability. Okay. This is the example there of the area underneath the curve there for a Z value here and a Z value there. Okay, so in this case here, you would have two. You'd have to use your table twice. And there's your negative 1.37, 1.37, and then your 1.68, 1.68, and you add those two probabilities up and you get about 86%, 87%, which actually looks right. That looks to be about 90%, in and about, right? These guys here, these examples, these are the exact same thing, but without a graph. Okay, but I've shown you there that in the margin, y'all can just create a little graph there to give you guys a visual representation, just to ensure that you guys get the right mark. Okay, and like if you look at this one right here, like if you got an answer of 24%, well, please, before you guys just fill in a bubble or fill in, choose an answer A, B, C, D, make sure that your answer verifies with your diagram. Maybe I've given you a diagram. Easier. Maybe I didn't give you a diagram. Take the 5 seconds, make the diagram. Okay? Ensure that you guys nailed it. And that's what these guys are here. Probability of Z greater than negative 1.73. Draw your graph, get an idea of where you're going. There you go. Okay? What else we got? This one here, working in reverse. So in this case here, I'm looking for the Z value, and I've given you the area under the curve. So here, the area under the curve is 0.2123, which is 21.23%. Okay? If I'm looking for the Z value, you just go in reverse. So find the number in the probability closest to that one. Okay? 0.2123. And you just reverse it, so it's 0.5, 0.56. So your Z value here is 0.56. Okay? Very good. And there are more of these guys here. Okay, finding the areas under the curve, or I've given you the areas under the curve, and I'm asking for the Z values. Okay? And then we get into the questions. And just the whole idea is I'm giving you guys a real life question with a real mean, a real standard deviation, and a real point. Okay? And I'm asking you guys to find the probability. Excellent question. So a survey by the National Retail Federation found that women spend on average $146.29 during the holidays. Assume the standard deviation is $29.44. Okay? So find the percentage of women who spend less than $160. So if I can somehow do this here, 146. So let's just go to... So, I've got my mean, which is, can I just make that bigger? There we go. 146, I think that's what it was, $146, okay? And then your standard deviation was, what was it, $29. So somewhere in there, there's your first one, there's your second, okay? Third, done. So each of these standard deviations is $29, $29, $29. So you're adding, and then in the negative, it's minus $29, minus $29, minus $20. So there we go. At least we've got a little bit of a visual happening. And I think that they wanted to know, find the percentage who spend less than $160. Spend less than 160. So where's 160 on here? Let me go with 160. I don't know. Well, our standard deviation is 29, so that should be in here somewhere. Somewhere in there. So that's where $160 is. And the question says that we want, okay, the amount of people there that spent less than that. So you're looking at what's going on here. All right. So let's go here. We need to figure out a Z score. So I gave you the 160. We need to convert all this in here. So you put that 160 into your Z table and you get a number there of 0.47. So that means there that this area is 0.47. Or sorry, the 160 minus that, what is happening here. I've done something. Sorry, that is, there we go. What we've done here is we found that this area, okay, is 0.18. And we found there that this area is 0.5. And where did we get this number? There is no table that will give you that number. Okay, you have to realize there that this whole area is 0.5. You found that this area here was that, so now you add them all up and you get a total of 68%. That's what we're looking there for that one. To try another one here, here we gave you mean, we gave you a standard deviation, and we gave you two numbers. So we want you guys to find the area between these two numbers. And it's, you know what I mean? In this case here, you would do two z-scores. You would find these values. You'd add them up, and away you go. So this is where we're at. That's basically what's going to be on the quiz there that'll open there this afternoon. And I have more questions that we can work on there together. But talk to me here. How are you guys doing? Is anybody even still there? I see. There's lots of them here. So talk to me here. How are we doing? How are we doing? You guys want to try some, what do we got? Yeah. Hey, Lloyd.
Sorry to interject, but like regarding the last question of the assignment, right? The formula for it to find the z value would be value subtract the mean divided by the standard deviation.
That's it.
When I've done that with the two numbers between 3,000 to 4,000, and that is reflective of this lesson.
Yeah.
Right. The options that were there was not reflective of any answer I could get.
All right. Well, I'll have a look at that one too. That was the last question.
Yeah.
So that was number 9 and 9D and the last question. I'll have a look at it. Don't worry. It's all good. It's all good. I just can't really talk about it right now because the assignment is going on, right? So, but it's all good. You guys are doing great. And, you know, ask questions. I love it. I don't know, maybe I think sometimes students, they get shy, or maybe they get the feeling there that, I don't know. You guys have paid your money. Ask as many questions as you guys need to. I love it. I love it. I really do. Okay. What do we got here now? I just wanted to show you. Where is that? That's not the right one. Okay. Now, I don't really have anything more other than these questions here that I'm going to post. And sorry, I'm just trying to find my weekly so that I can, this is what I'm looking for. Weekly. There we go. So, there we go. Have a look at this one right here. I'll post these there. I made a couple questions there last night. And these ones here, you'll see these ones again. This is where we're going. So, after surgery, to repair a torn rotator cuff, the post-surgical recovery time until patients are released from physiotherapy are normally distributed. That's key. That tells you there that we're dealing with this. There's a mean of 24.3 weeks and a standard deviation of 2.4 weeks. Okay? And if a patient undergoing rotator cuff repair surgery is randomly selected, determine the probability that they will have a post-surgery recovery time of less than 20 weeks. You see how silly wordy these are? That's welcome to where we're going. That's what the medical field is all about. Okay? And so we've got our standard deviation, we've got our mean, we've got our point, okay? And we're looking at less than 20 weeks. So just to figure out what's going on here, we've got our graph, and I've just drawn this there in the margin. There's my mean, 24.3 weeks. Doesn't have to be exact. It's just a visual representation to get a good guesstimate. And we're looking at less than 20 weeks. Well, our standard deviation is 2.4. So that would be the first standard deviation. That would be 2.4. So that would take us to 22. And then 2.4 would be about 20. So somewhere out here is 20 weeks. Somewhere, and we want less than 20 weeks. So it'll be all of this area. Okay? That's all we're looking for, is this area right here. Okay? And I do encourage you guys to draw this. Okay? I really do. All right? So we take our, we got to calculate our Z value. Okay? So we put 20 weeks minus 24.3 weeks. Okay, all divided by 2.4. There's your mean, your standard deviation. We get a number there of negative 1.79. Well, the negative makes sense because this number is below the mean, right? So we get negative 1.79, and we check our Z table, okay? And we get a number of 0.433. Now, that's 46%. That's a big banana. That's a lot of area. That's a lot of probability. Is that what the question is asking? The question is asking for the area outside of this 46.3%, right? So how do I find this area? Well, the whole side is 0.5 minus the 0.4633, and we get a wee little answer here of 0.0367. So that's the area we were looking for. Okay, and it's just, the key to this is being able to draw it and visually see what's going on. Okay, this one here, it's the same question, but it's asking for greater than 26 weeks. Well, there's your mean, 24.3, and 26 would be out here somewhere. Somewhere. Doesn't have to be exact. But you see, from this information here, we can extract that we're going to get a positive Z value because we're above the mean, and we're looking for greater than 26 weeks. So we're looking for all the area out here on the fringe. We're not looking for in here. We're looking for it out here. So you can kind of guess what we're going to do. We're going to find a Z value, and that Z value is going to measure from here to here, but we don't want to know this area. We're going to have to take the 0.5, the 50%, and subtract it from here. And that's what we've done. And you calculate your Z score, you get 0.71, and then you find your area under the curve, which is 0.26 minus that, and you get this value right here. Okay, so this is where we're at. Talk to me. I don't want this stuff to be trouble, and that's why I've given you guys a review week, and that's why you guys can, this kind of a free week there that we can just kind of walk over the same thing. And you'll see here in this example here, okay, I want you to find the area between 22 and 24. It's the same question. We're still talking about post-op surgery here, okay, post-op physiotherapy, and you've got there's your same mean, okay. And we want to know there between the value of the area under the curve there between 22 and 24 weeks. Well, so we're only looking for this small area right here. Okay? And you would do the same thing. You would find your two Z values. Okay? And just be careful. Look at the methodology here. Okay? And this is how this guy measures. We're looking for only this area. So how do we figure it all out? You got to subtract one area from the other. Okay, so have a look at this. This question here, it's another question here. We're talking about probably Tylenol or some type of ibuprofen there, suspension and child strength liquid suspension. Okay, and here we're talking about the amount of medicine there that one dose is about 5 milliliters, okay? But a lot of parents there, they just use a tablespoon or a teaspoon, and their measurements are off, and this is all normally distributed. Okay, so, and yeah, there we go. So what we've got here now, we've got a mean. A single dose of child strength liquid suspension pain reliever is 5 milliliters. A study revealed that parents tend to use a spoon rather than measure the volume with the cup provided. The volume of medication poured was normally distributed with a mean of 6.3 mils and a standard deviation of 1.1. So, okay, so I quick easy peasy draw. There's my mean, 6.3 mils. Okay, and then I've got a standard deviation will be 1 mil, 1 mil, sorry, 1.1 mil, 1.1 mil, 1.1 mil, and then the same in the opposite direction. Okay, so we want to know the probability there of a parent pouring less than 5 mils. So 5 mils would probably be here. We're going to get a negative Z value. All right, so less than 5 mils. So that means that I'm looking for all of this in here. Very important that you guys get this as far as being able to draw the graph, because the graph will help you guys to understand which direction you're going and how you're going to approach this, because every question is going to be different. Same idea, but different. Okay, and what we have here is we input there my Z value. You get 5 milliliters minus 6.3, which is my mean, divided by 1.1. We get a value there of negative 1.18. Okay, now what is that measuring? Because our table measures out from the mean, this value here, okay, is what we're going to get from our Z score. So if you look at the table there, negative 1.18, and you can look at your table just like we're doing right there, and we're going to get a value of 0.3810. That's the area, that's the probability of this area right here, 38%. We don't want that. We want this area. Okay, so how do you do it? This whole area is 0.5 minus the 0.38 there you just found, and this area here is 11.9%. Now, does this? Oh, just give me 1 sec. You okay. See the 11% here that we just found? It doesn't. That doesn't look like 11% because I drew it wrong. Okay, so don't worry. You know what I mean? But as long as that makes sense, obviously this guy should be out here more. Okay, and that's your 11.9% is this area out here. All right, good. Who is speaking? Talk to me.
It was Megan. I was just wondering if these were posted yet so I could print them off.
Oh, I'll post them there right after class there. I just made this there last night, okay. Just trying to. But yeah. These questions here are no different than the stuff there. This is from the week 11. From last week's PowerPoint. There's a couple of questions in here that deal with the same thing, different numbers, basically. And so these questions here are what you're looking for, okay? And I got these there from your book. These are this question here about post-op physiotherapy came right from your book. This question here about single dose of child strength liquid suspension, this one here came right from your book, okay? And so and this is in chapter 7a, 7.2. That's where all these questions come from. One little sliver of a chapter. Like, we didn't really do anything else out of chapter 7 other than this. So, yep. But Megan, they will be posted. Talk to me. What else we got?
Ian, I just have a question about going back to the probability and odds for the assignment.
Yeah. Talk to me.
So one of the questions was, what's the probability? And it was saying answer in ratio form. How do you take like a fraction and change it to a ratio form though?
Excellent question. I'll go new slide here. So you I don't know. Let's go. You see, See that one there for 4/15ths, right? And I'm writing it like that because I don't have my math program up and running, but that's 4 divided by 15. That's 4/15ths, right? And quick, easy peasy. There's your ratio.
But so, how are you supposed to do it? So, like, one of them you can't technically, like, it wasn't an answer given, that's why.
No, that's all right. Which one was that?
That was number 3. It's what are the odds of 5/12?
All right. So
You can't reduce them either, so that's why I was curious.
just when it comes to odds, be careful. Like if I say here, I'm just going to make one up here. What are the odds of an event happening if the probability is, I don't know, I'll just keep it 4 divided by 15. So here's a question here. What are the odds of an event happening if the probability is 4 out of 15? So now, what is my formula there for probability? Is equal to, what is it? Desired divided by undesired, right? Or sorry, desired divided by total. Okay, total number. And then we have odds is equal to desired divided by undesired. And be careful because some students are getting tripped up. When I'm asking for odds, they're giving me a probability. Don't. Different bananas. And I'll show you guys an example here. So your probability is desired divided by total number, and your odds is equal to desired divided by undesired. So let's have a look at this one right here. What are the odds of an event happening if the probability is 4 over 15? Now, what does 4 over 15 mean? It means desired is 4, and the total number is 15. Okay, I'm asking for the odds, and odds is desired divided by undesired. So, how would we do this here? If I was looking for the odds, is equal to desired divided by undesired. So, what am I doing here? It would be 4, because that's my desired. Now, how many, my total is 15, how many is my undesired? Anybody? 11. Okay. So in this case here, well, my probability of the event happening is 4/15. The odds of this event happening are 4 over 11. Okay? Or you could write it like this. So just be careful when it comes to there's a couple of questions there where I ask for odds. Be careful. It's not the same formula as probability. Okay? And you guys we can reduce ratios like 10 to 100. I can reduce that just like a fraction. 10 divided by 100 is equal to 1 divided by 10, which is equal to 1 to 10. All these different ways of working this, okay? Brandon, how was that? Talk to me. What's going on?
That helps. I'm just curious, though. So is it basically to figure out your undesired? It's basically whatever your desired is, like your total of the number minus your desired?
The total minus the desired will give you undesired. Does that make sense? Well, total minus desired
equals your undesired.
Yeah. Welcome to the language specifics of a statistics math course.
Yeah. So then, for number 5, though, I don't know if that answer is technically there then.
All right. Well, we'll have a look at it. I've got. I'll update there And I'm gonna give an extra day. And if people need it, it's all good. If they don't, they don't. It's all right. We have time. And that's the nice thing about this course is I've designed it there that there's really no more work coming in. We can just kind of work on what we've done. So don't worry about it. I'll send an announcement out and I'll check these questions there. And anyway, it's all good. It's all good. We'll get it all straightened out. What else
I have another question though.
Yeah. What do you got?
So it's doing probability without replacement. I keep getting confused with that, and I keep looking at the textbook and stuff.
Oh, yeah. I've kind of streamlined it, so we're kind of all wearing like kind of horse blinders. You know what I mean? And the book is good. It's really good. But it's in a lot of ways is too much. So
because I even looked through the PowerPoint too, and I was trying to figure out like when you're using like replacement and without replacement. Are you using the multiplication rule?
That's it. The only time you will see a replacement with replacement or without replacement is when you're choosing 2 cards. Or you could choose 3 cards or 4 cards, right? And the probability and the key words for that is and then. So whenever you see and then, it'll be multiply, and then you got to be careful of, is it with replacement or is it without replacement? Talk to me, Brandon.
So, well, I'm just looking at, like, 2B was what's the probability of selecting 2 marbles without replacement?
Yep.
So, like, I was able to figure out the first one, which was with replacement, but...
So let's try one right here. Let's try another one here. I'll just do a new slide. So bag has 5 red marbles and I don't know, man, 12 green marbles. Find probability of choosing 2 red marbles without replacement. Okay, so find the probability of choosing a red marble. I guess I should say choosing a red marble and then another red marble. There you go. So there's your keyword, and you see I've made it capitalized. I wouldn't do that on a test or anything, but you guys have got to be looking for it. Okay. So in this case here, we've got a bag of marbles, 5 red, 5 green, and find the probability of choosing a red marble and then another red marble without replacement. Okay, so I'm going to choose a marble. I'm going to put that in my pocket, and I'm going to choose another marble. Okay, if it was with replacement, I would choose the first marble, and then I would put that marble back and then choose again. So in this case here, how would we do this here? Probability, okay, is equal to, what's my formula for probability? Desired divided by total. So I've got 5 divided by 17, right? That's the probability of choosing the first marble. And where did I get these numbers? Well, 5 red marbles, there's 12 green, so there's 17 in total. Okay, so 5 divided by 7. And because it's an and then, okay, I get to multiply. And now, without replacement, okay, here I go 4, because in theory I've already chosen the red one, okay, divided by 16. And that equals a certain number, whatever it is. Okay, that's how we do that one. Let's try another one here. I'll duplicate this slide and I'll change it. Let's say I want to go red and then a green marble with replacement. Okay. So bag has 5 red marbles and 12 green marbles. Find the probability of choosing a red marble. I got comic books on the brain, I guess. Red marble and then another green marble with replacement. Okay? So, how do we do this? Because it's and then, it's going to be multiply. So find the probability of choosing a red marble. Okay, so it's 5 divided by 17. So I got 5 marbles and there's 17 marbles total. So 5 divided by 17, that's good to go. And then another, choosing a green marble. Well, what's green going to be? There are 12 greens. Okay. And with replacement, did I put that first marble back? I did. So there we go. And then we multiply these guys out, and that is our probability for choosing a marble. There's the examples there of with replacement or without. So if there's an error on there, it's all good. We'll go and get it fixed. And but don't worry, this is where we're at. Your the quiz 3 that's going to go out there this afternoon, it's ready to go, but I'm just going over it again. I'm going to try, I've been working on this for about a week now, not like the assignment where I kind of just threw it together and, well, the assignment was ready, but then I changed it into an e-portal version. But I want to give you guys a paper copy, gives you guys something there to work on during the week, and the e-portal there, I want that to go as well. And we're going to try it again. I'm determined. And we'll try it again, and hopefully there the quiz is a little better than the assignment. But all is well, all is well. Talk to me. What else we got? Brandon, how is that?
Yeah, I'm still confused, but I'll figure it out.
Well, talk to me. What is confusing you about this one right here?
I think it's just more the without the replacement part, just because. So, like, I'm trying to do one of the questions, and, like, I'm doing it, and I'm like, I think I got it, but it's, like, the answer's not, like, I don't know, I'm just, like, still confused.
Well, it's all right. The without replacement, you just knock one of the, and let's try another one here. Let's try this one. Maybe this will, find the probability of choosing, we'll do the same question as we just did. So, let's have a look here. Maybe this one will help Brandon. A bag has 5 red marbles, 12 green marbles. Find the probability of choosing a red marble and then a green marble without replacement. So, the bag has 5 red marbles, and we're looking for one of them. So we've got 5 divided by 17, okay? And then a green marble without replacement. Okay, so I've chosen the first marble, and now I'm down 1 marble in the bag. And you see how that will change the probability. So if you're not replacing that card, if you're not replacing that marble, that second one is going to be down 1 from the total. If it with replacement, that number will be the same. These numbers here will be the same. That's how the with replacement and without replacement works. You want to try another one? How'd that one go?
Yeah, I'm still lost. Like I said, I'll figure it out somehow.
We've got time after, and let me know. We'll set up a WebEx and we'll get it going one-on-one. It's all good. We have time. We have a week. That's why we do this, and to iron things out. And in a week, y'all will be laughing. Trust me. Yeah. So, Brandon, email me. We'll set up a WebEx there, or stick around there after. But this is where we're at. The quiz, which will open there this afternoon, it's exactly the same as the assignment and the test. It's kind of all the same thing. And I didn't want, we could go into T-tables and these kinds of things, but it's not my goal. And the goal of this course here is this stuff right here. And I think you guys would be just fine. Just keep at it and keep emailing me. That's where we're at. So, how are we doing there? Do we have any questions? why don't we take a little 10-minute break? I gotta go see if my kids have robbed a liquor store or something like that, or I don't know where my kids are. I don't hear them. They're too quiet, and that's dangerous. It's dangerous. So why don't we take a 10-minute break? And actually, it's 9:46. Let's meet back here at 10. And if there's any questions that are going on there, any specific questions there with the assignment or this and that, let me know, and we'll come back. I'll be back here at 10. Please stick around. Go get a coffee. Go and take a break for 15, and we'll see you guys back here in 10. How does that sound? Everything okay? Please come back. I'll be back here. Okay? Not leaving you guys. I will get her done. Okay? We'll see you guys in 10, 15, at 10 o'clock. Bye. What's going on here? I gotta stop this.